Welcome, curious minds, to another deep dive.
Great to be here.
Today, we're plunging right into the heart of modern Vue.js development. We're talking about the Vue 3 Composition API.
Yeah, a really important topic.
Our mission for you, the listener, is pretty clear. We want to cut through any confusion and give you a really rock-solid understanding of this powerful feature. So whether you're maybe a seasoned developer migrating from the Options API, or perhaps you're just starting your journey with Vue 3, you're going to walk away well-informed.
Absolutely. We'll try to unpack why it even exists, how it works.
And how it really changes things for Vue development,
Exactly.
right?
It's quite a fundamental shift, honestly, in how we structure Vue apps. Understanding its core ideas can really enhance your development process.
Yeah, I did that.
What's interesting, I think, is how it emerged to, solve problems that became pretty challenging as Vue applications got bigger and bigger.
Okay, so let's unpack that why then.
Yeah.
For a long time, the traditional Options API was just how you did things in Vue.
It was a standard, yeah.
But as components grew, what were some of the biggest limitations? What were the main pain points developers were hitting?
That's a great starting point. So imagine you have a large component, maybe something for managing user profile settings, lots of moving parts.
Right.
In the Options API, the logic for just that one feature, fetching the data, saving changes, maybe input validation, displaying derived info, it would be scattered.
Scattered where?
You'd find bits in data, other bits in methods, maybe more in computed properties. It was all over the place.
Oh, okay.
And as components got bigger, it made them incredibly hard to read, hard to maintain, even hard to work on as a team, because the code for one single logical idea was just split apart.
So if the Options API led to that kind of scattered logic, how does the Composition API fix that? What's the core shift?
The core idea is actually pretty simple. Instead of organizing your code by option type, like data or methods, you organize it by feature.
By feature, okay.
Yeah. The Composition API lets you group all the related logic for a specific feature together in one place.
I see.
And that just dramatically improves readability and maintainability, especially when components get complex. Everything you need for, say, user profile settings is now logically grouped. Much easier to understand and modify.
That sounds like a huge win just for code organization.
It is.
And you mentioned maintainability, but I also remember reusability being a real challenge sometimes with the Options API. It felt surprisingly difficult to, share stateful logic between components.
You've hit on a really crucial point there. If you had some piece of stateful logic, maybe a complex counter or a custom data fetching thing.
Yeah, something you built once and wanted to use elsewhere.
Exactly. It was genuinely hard to just pull that logic out and reuse it cleanly across different components without resorting to, patterns like mixins.
Right, mixins. They had their own problems, didn't they?
They often did, yeah. Things like naming conflicts, unclear origins of properties. It could get messy.
So the Composition API.
The Composition API introduces Composables. These are basically dedicated functions specifically designed to abstract and reuse exactly that kind of stateful logic.
Composables. Okay, that sounds like the answer then.
They're a real game changer for code reuse, yeah.
And for our listeners who really value type safety, especially folks using TypeScript, how does the Composition API stack up compared to the Options API there? Were there issues with TypeScript before?
That's another key area where it shines. The Options API, it had more limited type inference, often meant you needed more explicit type declarations, or the type checking wasn't quite as robust as you might like.
Right.
The Composition API, because it really just embraces plain JavaScript functions, is inherently TypeScript friendly. Much better type inference, better safety right out of the box.
That sounds like a big plus for bigger projects.
Huge benefit, yeah. For maintaining code quality, for smoother collaboration. And really, all these points together, grouping by feature, these powerful composables, the great TypeScript support, they all lead to a more organized, more modular, and just fundamentally more scalable project structure.
Okay, that paints a really clear picture of the why behind it all. So if the Composition API is this powerful new way of doing things, where do we actually start when we're writing a component? I'm guessing this leads us to the setup function.
You got it. Setup is your main entry point. It's kind of special because it gets called before the component instance is even created.
Before, okay.
Yeah, really early, which makes it the perfect place to, set up all your reactive state, define your methods, integrate lifecycle hooks, that kind of thing. Think of it as the foundation block for your component's logic.
And everything inside it is local.
Yep, scoped locally to that component, helps keep things tidy, prevents naming clashes.
Now, this next bit feels really important, especially for beginners. Anything you define inside setup, variables, functions, reactive stuff, if you want to use it in the components template, you have to return it, right?
Absolutely crucial. If you don't return it from setup, your template simply won't know it exists. It won't see it.
So if I make a count variable and an increment function,
You just return count increment at the end of your setup function. It's this explicit return that makes the connection. It's a clear contract between your setup logic and your template.
got it. Okay, let's talk about reactivity itself. It's really the core of Vue, isn't it?
It really is.
And with the Composition API, we seem to have two main tools for making data reactive, ref and reactive. Let's start with ref. What's that one for, and what's the key thing to remember?
Right. So ref is your go-to for making primitive values reactive. Things like, numbers, strings, booleans, simple stuff. The absolutely key detail here, and honestly, this is something that often trips people up at first, is that to access or update the value of a ref in your JavaScript code, you must use its .value property.
Ah, the dot value.
So if you have const count resup 0, you'd write count.value plus plus to increment it, not just count plus plus value. You need that .value.
I could see how that would cause some head scratching initially. But then in the template, it's different.
It is. There's a bit of template magic, as you say. In your components template, Vue is smart enough to automatically unwrap the .value for you.
Oh, nice.
So you just use the variable name directly. If you have that count ref, you just write in your template. Vue handles the .value access behind the scenes. Seamless.
Okay, so ref, for primitives, need dot value in the script, but not in the template. What about reactive then? When do we use that one?
Reactive is designed specifically for making objects and arrays reactive.
Complex type.
Exactly. When you pass an object or array to reactive, it returns a proxy of that object. And the significance of that is you access and update its properties directly, just like a normal JavaScript object. Absolutely no need for .value.
Oh, okay. So an example.
Sure, if you have constate reactive, you just increment it with state.count plus ifia. Feels very natural, very direct.
So for you, the listener, this is really the core distinction to grasp, isn't it?
I think so.
Is for your simple primitive values, and you've got that .value requirement in JavaScript.reactive, is for more complex nested state like objects and arrays, and you access properties directly.
Like a critical takeaway, yes. And another point is that reactive provides deep reactivity automatically for objects. So if you have nested objects inside, changes deep down will still trigger updates.
Whereas ref is shallower.
Ref is shallow by default, unless the value it holds is itself something reactive, like another ref or a reactive object. So for clarity, the general recommendation is often use ref for individual simple values, use reactive when you're grouping related state together into an object or an array.
That makes sense. It's a good rule of thumb. Okay, beyond just reactive state, we often need values that kind of automatically update based on other state, right? Like a calculated total or maybe a formatted string. That brings us to computed.
Exactly. Computed is precisely for that. It lets you create a reactive value that automatically recalculates whenever its underlying dependencies, the reactive things it relies on, change.
Efficient too, I imagine.
Incredibly efficient. It caches its result. It only reevaluates when absolutely necessary when one of its dependencies actually changes.
Nice. Any catches?
The main thing is that a computed property is inherently rate-only. You can't just assign a new value directly to a computed property. It's derived.
Okay, so how would that look?
Well, if you had our count ref from before, you could create something like const doubled computed count.value2. Now, doubled would just automatically update every single time count.value changes.
Very neat for deriving values. Okay, now beyond deriving values, sometimes we need to actually do something when data changes. Trigger side effects, maybe.
Right.
Yeah.
API calls, timers, logging, that sort of thing.
This brings us to watchers. And Vue gives us two main types here, watch and watchEffect. Let's start with watch. What's its main job?
Watch lets you explicitly observe a specific reactive source. That could be a ref, a reactive object, a getter function, or even an array of multiple sources.
You tell it exactly what to look at.
Exactly, you're explicit. It's best for performing those side effects that need to happen only when some particular piece of data changes, like only call the API when the user ID changes.
Okay.
And useful feature of watch is that it gives you both the new val and the old val of whatever you're watching. Great for comparisons or conditional logic based on the change.
So you can watch one thing, like count, or multiple things.
Yep, you can pass an array like watch, source A, source B, new values, old values. Very flexible.
And then there's watchEffect. That sounds a bit different, more automatic.
It is, yeah. watchEffect is quite powerful because it automatically tracks all the reactive dependencies that are accessed inside its callback function.
So you don't tell it what to watch.
Nope. It figures it out implicitly based on what reactive things you use inside the function you give it.
Interesting. And when does it run?
It runs immediately when it's first defined, and then it reruns automatically whenever any of those track dependencies change.
Immediately. Okay.
So if you wrote watchEffect console.log count is now.count.value,
Yep.
it would log the current count straight away, and then it would log again every time count.value changes later on.
Okay, so if I'm trying to decide between watch and watchEffect, what's the main difference I should focus on? When do I pick which one?
The core distinction is that explicit versus automatic dependency tracking.watch needs you to tell it what to watch. watchEffect figures it out automatically based on usage.
Okay. Also, watch is lazy by default. It only runs after the first change happens unless you configure it otherwise. watchEffect runs once immediately, then again on changes.
So, use cases.
Watch is probably better when you need to perform side effects only when specific data changes and maybe you need the old value for comparison.
Yeah.
watchEffect is great when your side effect depends on any number of reactive things within its scope, and you often want that initial run right away. Think like automatically fetching data based on several reactive inputs.
Got it. That clarifies the difference. Now, thinking back to the Options API again, you had that dedicated methods section for functions. How do methods work in the Composition API? Is there a special place for them?
Nope. Much simpler. Methods are just regular JavaScript functions that you define directly inside your setup function.
Okay.
There's no special syntax, no separate methods option needed. That increment function we talked about, you just define it like constant increment, count.value plus right there inside setup.
And then just return it if the template needs it? Exactly. If you want to call it click increment in your template, you just make sure increment is included in the object you return from setup. Simple as that.
Nice and straightforward. What about lifecycle hooks? Things like mounted, updated, unmounted. Do those still exist?
They absolutely do. All the traditional Options API lifecycle hooks have direct equivalents in the Composition API.
How do you use them?
The key thing is you import them directly from Vue. So you would import onMounted, onUpdated, onMounted from Vue, for example.
Oh, you import them.
Yep. And then you just call them as functions inside your setup function, passing your callback. So instead of having a separate mounted option block, you'd just call onMounted. Console.log component right within setup.
So it keeps all the setup logic, including lifecycle stuff, kind of grouped together in setup.
Exactly. It keeps things very cohesive within that one function.
Okay. Now, you mentioned Composables earlier as this big solution for reusability. Let's dive back into that. How exactly do they work, and what makes them, as you put it, such a powerful tool for scaling Vue apps? This feels like a real scalability superpower.
It really is the primary mechanism for scaling logic reuse, I'd say. So a composable, at its core, is just a plain JavaScript function. Nothing magical about its definition.
Just a function.
Just a function. But crucially, inside that function, it encapsulates some reusable logic, and it leverages other composition API features like ref, reactive, computed, watch, whatever it needs.
Okay.
The massive benefit is that this allows you to abstract and then share complex, often stateful logic across multiple components very easily.
And that helps with the...
Well, it doesn't just improve code organization, though it does that too. It drastically cuts down on code duplication. It makes the logic itself easier to test in isolation. And it really fosters a more modular, almost like a plug-in style approach to building features.
Like creating little reusable blocks of functionality.
Yeah. Precisely, which is absolutely essential for large maintainable applications, especially when you have multiple developers working together. It promotes consistency.
Can you give us a quick, simple example? Like, what would a basic counter composable look like?
Sure. Imagine you create a separate JavaScript file, maybe call it useCounter.js. Inside that file, you define your counter logic using Composition API functions.
So like ref for the count.
Exactly. You might have something like .importRef from Vue, export function use counter, const increment count.value plus plemon, return count increment.
Okay, so it defines the state and functions
Right.
and then returns them.
Right. Then in any component setup function where you actually need this counter functionality,
You just import
you can just import useCounter from .useCounter.js, and then inside setup you call it const count increment increment use counter, and now you have that reactive count and the increment function available, ready to be returned and used in your template.
Wow, that's incredibly clean.
It is. It promotes true modularity, keeps component setup functions focused on orchestrating logic rather than containing all of it, and encourages a really consistent approach across your whole application. Super powerful.
Yeah, I can really see the scalability benefit there. Okay, so for our deep diver listener, let's try and distill some best practices based on everything we've covered. What are the key takeaways?
Absolutely. Let's summarize. First, use ref for your reactive primitive values, numbers, strings, booleans.
Right.
Use reactive for reactive objects or arrays, especially when you're dealing with more complex or nested state.
Makes sense.
Use computed to derive new reactive values based on other reactive state. And remember, those are read-only.
Got it.
Use watch when you need to respond to specific targeted data changes, often for performing side effects like API calls, and maybe you need the old value.
Explicit watching.
Explicit watching, yeah. Use watchEffect when your side effect needs to react to any reactive state that gets accessed within its callback, and you typically want it to run immediately when defined.
Automatic watching.
Automatic watching. And, crucially, organize your reusable stateful logic into composables. That is really the key to scalability and maintainability.
Composables are king.
Pretty much. Also, integrate your lifecycle logic using the on equivalents, like on-mounted, on-updated, directly inside setup.
Keep it all together.
Keep it all together. And finally, for a better development experience and type safety, definitely leverage TypeScript with the Composition API. They work beautifully together.
That's a great set of guidelines.
Sure.
Now, for all the learners listening, what are some common pitfalls, things to watch out for as they start using this? You know, the moments that can cause some head scratching, what's often overlooked?
Oh, yeah. There are definitely a few common ones I've seen trip people up quite often.
Like the dot value thing.
That's probably number one. Forgetting you don't need dot value when you're accessing a ref inside your template. Vue unwraps it automatically. So writing count dot value in the template is redundant and incorrect.
Okay, good reminder.
Then the flip side. When you're modifying a ref in your JavaScript code, in setup, or a composable, you must always use .value. Forgetting that is super common. It has to be count.value plus a, not just count plus a. The second one won't trigger reactivity correctly.
Big one. Okay, what else?
Returning from setup. We mentioned it, but it bears repeating. Anything data, functions, computed properties that you want to access in your template must be explicitly returned from the setup function inside that returned object. If you define my var but forget return my var, it's just invisible to the template.
You gotta return it.
Gotta return it. And finally, mixing the Options API and the Composition API within the same component. While Vue technically allows this,
Probably not a great idea.
for clarity and consistency, it's generally recommended to stick to one paradigm within a component once you decide to use Composition API for its main logic. Trying to blend them too much can make the code harder to follow and reason about. Commit to one style per component, usually.
Excellent advice for navigating those initial hurdles. Okay, finally, for those who want to keep digging even deeper after this, what are some bonus tools or resources they should check out to really master the Composition API ecosystem?
Yeah, there's some fantastic resources out there that build on these core ideas.
Right.
First, Vue use. It's this huge collection of incredibly useful pre-built composables for almost anything you can think of managing browser APIs like mouse position or local storage, state utilities, animations. It's a gold mine.
So reusable logic someone else already wrote.
Exactly. Great for learning patterns and saving time. Check out Use Mouse or Use Local Storage.
Cool. What else?
If you need more robust state management beyond simple composables, Pinia is the way to go. It's the officially recommended state management library for Vue now, specifically built with the Composition API in mind. It's very intuitive, lightweight, and integrates perfectly.
Penny, okay. Replacing Vuex, essentially.
It's the modern successor, yeah. A much simpler API in many ways. And of course, the Vue dev tools.
Can't live without those.
Absolutely essential for inspecting your reactive state, seeing how ref and reactive are working, understanding component structure, debugging performance. It's an indispensable companion for any Vue developer, especially with the Composition API.
Fantastic set of tools for continued learning there.
Okay.
So let's do a super quick recap of those core Composition API functions, just like a mental checklist you can take away.
All right. Let's do a cheat sheet.
Go for it.
Ref. For making primitive values reactive, remember .value in script.
Yeah.
For making objects and arrays reactive, direct property access.
Okay.
Derived read-only reactive values, auto updates. For targeted observation of specific reactive sources, side effects, explicit.
Gotcha.
Automatic dependency tracking inside its callback, runs immediately. Implicit.
Lifecycle hooks.
Use the on functions like on-mounted, on-updated, inside setup.
And the big one.
Composables. Your functions for encapsulating and reusing logic across your application. The key to clean, scalable code.
Perfect summary. We've really taken a deep dive into the Vue 3 Composition API today. We've seen how it elegantly solves the limitations of the older Options API.
It really does streamline things.
And it's not just about, new syntax. It's a fundamental shift towards building more organized, more reusable, and ultimately more scalable code.
Yeah.
Hopefully you, the listener, have now gained a shortcut to understanding these core principles.
Principles that enable much more robust and maintainable Vue applications, for sure.
It's a powerful paradigm shift that should serve you well.
Agreed.
So as you go forth and start building with this, or maybe refactoring existing code, here's a final provocative thought for you to mull over. Think about how that central principle of the Composition API, grouping logic by feature, how that reflects a much broader trend we see in software development generally. This move towards modularity, towards separating concern.
It's definitely part of a larger pattern.
How might internalizing this idea influence how you approach structuring other parts of your projects? Maybe even how you think about building systems beyond just front-end frameworks. Consider how really mastering this concept of feature-based organization could empower you to design more adaptable, more resilient architectures in all your work.
That's a great point, thinking about modularity at different scales.
Something to think about. Thanks for joining us on this deep dive.
My pleasure.